Everyone. Good day to you all. I hope everyone is doing well. Today is our physics session, and I welcome all of you to this page. First of all, we thank God for securing the second position in our Zone 2 athletic competition. We are doing great, and we thank God for that, just by the way. What are we going to learn today? It's not anything abstract, but something we know before, and we are aware and we interact with every day. As I always say, physics is not an abstract, it's a daily activity. Looking on the screen, we have the structure or the model of an atom on it. So it tells us that the things we are going to study, they have a relation to atom. All right. What are we going to learn? It's not anything but matter. Wow. And this is your teacher, Moses Adazaria. Thank you. Now the topic we are to study is under the strand mechanics of matter, of which the strand that we are going to study specifically, which is the substrand, is matter. By the end of the lesson, each student will be able to define matter. One, you will be able to identify and name the 5 states of matter recognized in modern physics. Also, students will be able to describe the particle arrangement and motion in solid and liquids. They will be also to differentiate between the solid liquid based on the shape, the volume, and how they flow, and even the energy contents. Let's begin. Then, what is matter? As we say, let's think, what is matter? Before we think, let's look through our environment and look at the things we can see and mention their names possibly. I have a book, an apple, glass of water, and a balloon. These are my very things within my environment. What are yours? Now all these things come together, or all these things fall under the topic or the concept matter. Then what is matter? Are we there? All right. In simple terms, it means that anything that has mass and can occupy space. If you say edible, we don't eat balu. If there's nothing that you can use these following objects on my screen to describe, if not simply they can occupy space and they have mass. That is what is making all of them falling under one umbrella called matter. So matter is anything that has mass and occupies space. Now all the physical things around us are matter. Standing from air to the very metals, they all form matter. Very good. Then someone will ask, what is the essence of this matter thing? If you understand the state of matter, it will help you explain physical properties. You understand the energy transfer and how even the things within our environment, they change from one to another every day. Then what is responsible for them changing from one to another? Is because of how the particles are arranged. It's also how the particles move and the kind of force holding the particles together. Wow. Then let's move on. Then what are the states of matter? The states of matter recognized under the modern physics are 5. What are these ones? The ones you are possibly thinking about, they are the one. 1, solid. You are thinking about the next, correct? The last, or not the least, correct? Gas. What could be the fourth? The one you are thinking, plasma. Then what about the fifth? It is called Bose-Einstein condensate, known as Beck. If you look at the name, it is written Bose-Einstein, Bose-Einstein. It means that two scientists discovered this state, and the scientist happens to be Maxwell Boltzmann and Albert Einstein, the famous physicist. Now, if two people do a work and we want to acknowledge their efforts by naming the thing after them, we take their surnames and use hyphen between them. So, Bose is the surname of Maxwell and Einstein is the surname of Albert. Put together, we get a state called Bose-Einstein condensate. Thank you. Now, let's see what brings the differences. The states differs because of how the particles are arranged, because of how the particles move. Also, the kind of force holding these particles together. And then the shape and volume and the energy content of these particles. Okay, let's move on. We have been using the word particles. What are the particles in this context? I usually tell you that we lack words, so one word can be used for several things. Therefore, if you are studying a thing in any concept, you have to ask, what does this thing stand for? The particles in this our context can be anything, but not everything. The anything that you're talking about here is it can be an atom. It can also be a molecule. In chemistry, you know what an atom is? The smallest of the elements that forms part in a chemical reaction. So we can have an atom like hydrogen atom, oxygen atom. Now these are particles. Now two or more atoms can come together and be a unique particle. And that particle will be a molecule. So for instance, if I have two oxygen atoms joining together with hydrogen atom as we have here, then we can call this also a particle. So don't be confused. We will get to a point where we will be saying atoms. We will get to a point where we'll be saying molecules, and we keep interchanging them because the molecules, the atoms, are what we are considering as particles. So for simplicity, we will be considering the particle as a single unit. A single unit, I mean, we'll be considering always a circle or a dot. We will be considering something like oxygen, two hydrogens on oxygen, and we consider this whole thing as a particle. No, we will just consider a single dot or circle for simplicity. But the circle could be a molecule or it could be an atom. All right. Now, we also heard about the word intermolecular forces. What is the intermolecular force you are talking about here? If you look at this, I told you that we will be considering it as dots. It means that this whole thing can be considered as a dot. Let me try to shade it and make it appear as a dot. If this one to appear as a dot, then this dot is a particle, this dot is a particle. The force between them is what we call the intermolecular force. We are not using interparticle force because it is also a thing or a topic under study somewhere. So we can't coin our own terms here by saying interparticle force. But we rather use the word intermolecular force. And we will also say interatomic force because from our previous page, Here, we said that the particles can be atom or molecule, but we will stick to one dot. But when we move ahead, we will be using intermolecular forces, but we can't say interatomic forces because of a special reason, of which in chemistry you dive into understand better. So understand the terms so that you won't be confused. Thank you. Then let's take the states one by one. Let's consider solid. You have now agreed with me that the particles are the things that comes together. So here, let's consider the ice cube here. If you view this ice cube microscopically, you are going to see the molecules of the ice as the circles. As I told you earlier, now how these molecules are arranged is what qualified this object to be called solid. The kind of forces holding them together also determines how they are arranged. Also, how they are arranged determines how they are freely to move. And how they are freely to move also determines the energy they possess by virtue of their motion. All right. So, first of all, we have to understand the nature of solids. What is the nature? One, the particles are closely packed, as we can see here. So, if this is atom, of a particular substance, the atoms are closely packed. If it's a molecule, the molecules are closely packed. And we don't want to say atoms and molecules, so we say the particles are closely packed. We also say that there is a strong intermolecular forces holding particles together. What can keep these support two close? Unless the thing is very strong. If not, they would like to move apart. So the force holding them together is very strong. What else? Because what is holding them together is very strong and they are also packed together in a close way, they don't have freedom to move. So what they can do is to shake their body small. So it's like we packing large number of students in a small room. If students cannot move, the only thing you can do is to shake your body. It means you are only vibrating. What we say is that the particles vibrate about fixed position but do not move freely. You can't. If we pack all of you in one classroom from science 1 to science 5 or in one classroom, which is maybe science 1, it's going to be difficult for you to even turn your head. And that way, we classify you as what? Solid. Then what do we say? If you cannot move, then you are having a low kinetic energy. Because what is kinetic energy? Is the energy possessed by a body by virtue of its motion. If an object is moving, then the movement is having an energy, or the movement causes the object to possess an energy. That energy is simply because it is moving. So if you are not moving, you are not having that energy. So if you are moving slow or you are even vibrating, then possibly the energy because of movement will be slow or small for you. All right, let's move on. I hope we are following. All right, thank you for your attention. Now, our next concept is the properties of solids. Properties of solids. What are the properties? If something is having the nature that we have described so far, what are the properties, the characteristics that you can see about the thing? First, they have definite shape. Their shapes are defined, definite, a shape that is known. Now, if you have a solid, you can cut it to any shape you want. It's not that the shape is fixed, but it's known. If it is cut in rectangle, it's having a rectangular shape. If it is cut in circle, it's having a circular shape. If it is a square, it's having a square shape. All right. Now they also have definite volume. If you cut a particular block or wood and the volume is 30 meters cube, if the wood is not wet, where it will dry up, but it's dry, that volume is going to remain the same throughout. Now, the space occupied by your mother's fridge, it will be that same space throughout. And that is the volume. It doesn't change. And it's also having a high density. Why? Because density is equal to mass over volume. And the way it is, when you pick a given volume, the atoms are closely packed. The atoms are closely packed. So if each atom is having a mass of 1 kilogram assumption, look at the number of atoms packed in this small volume. Let's say we have 1,000 of them, and let's say the volume is 10. It means that the density is going to be 100 kilogram per meter cube. Are you getting it here? So that is why we are saying it's having a high density when you compare it to other states. Let's move on. Also, they are almost incompressible. 99% of the times, you can't compress them. The way they are packed, how do you pack them again? There's no better way to pack them again. That makes them incompressible. And they can flow. One particle cannot move over the other. You can only shake yourself at your own place. That's the whole trick. Now, example is anything you can think about that is having all this description: an ice, a wood, an iron, a stone, a salt, crystal. But please take note. We give these examples based on their nature under normal condition. Under normal condition. If you go and put an iron, which is a metal, in a furnace, it will melt and become a different thing. But under normal temperature, all iron are what? Solid. For instance, a stone. Under normal circumstance, every stone is solid. But if you enter the core of the earth, where we get rocks from, they are liquid. So we classify them under their normal environmental condition. Now, what do we use solids for? They can be used for a lot of things. We can see it on the board: pliers, jackhammer, bulldozer, forklift hammer, saw, clog, submarines, force, teeth, whatever, everything you can think about. We have them in solid form. So building materials, cement and iron rods, the steels, they are solids. Electrical conductors, the copper wires and the aluminum cables and everything. We can talk about the household items: your mom's table, the chair, your television set, your bowls that you are eating inside, and the rest. And the last, we can talk about the tools and the machines we use around. They are all made up of solid components. All right. Then let's move on to the next state. And our next state is liquid. So let's look at this diagram here. We have water, and if we zoom the water microscopically to look what is inside, then this is what we are seeing. We are seeing the particles of the water arranged in a particular way, and they have spaces in between. Wow, this is like as in chapel, we have spaces where Father Kirk and the rest they can move through to check on you, and you, the students, are the circles. And beside that, if Father Kirk and Co are not moving, the students themselves can move through the spaces. If something is like this, then it is a liquid. Wow. Then let's look at the nature. The nature of liquids is that the particles are close together but not fixed. You can see that some are on each other, but they have spaces they can navigate their way through. Also, the force holding them together is weak, especially the force between this and this. You can say is strong, but the force between this, let me use the force between this and this, we can say they are lying on each other, so they are strong. But the force between this one and this, so let me say this is B and this is A. Then the force between A, B, and C, and possibly D is weak. Now, logically, this one is not really attaching itself to this. But because the picture is 2D, you may not be able to see all. Are we getting it here? For instance, two people can stand in a way that when you snap a picture, you would think one is attaching himself to the other, but there's really a gap between them. That's what you are seeing. So don't assume that this one, for instance, is attached to this one and there's a space between this and this. No, there's a space between all of them, but because of the image, it appears that some are lying on each other. So that's a trick. All right. Also, the particles slide over one another. It means they can move or they flow. That's the whole thing. And then, if you can move over one another, in the course of movement, you possess an energy called kinetic energy. So they possess a moderate kinetic energy. The moderate here is because we are comparing to something. That's why we are saying moderate. Compared to solid, it's having higher energy. But to someone, it is not. So we use the word moderate. All right. Then what are the properties of liquids? If you look at the diagram, we can see. Now, what do we see? What we see here is that no fixed shape. If you have water, it depends on where the water is. Then you have the shape. The one in sachets or sachet rubber is having the shape of the sachet. The one in Venna bottle is having the shape of the Venna bottle. And the one you pour on the floor will have the shape of the floor. That's what I'm trying to say. Also, they don't have definite volume. Sorry, they have definite volume. Now, what do we mean by their volume is definite? Now, if you pour out your Venna water, if you pour it from 500 milliliters container, if you even send it to abroad, it is still 500 milliliters. If you bring it to the lab and we pour it in a measuring cylinder, we are still going to get 500 milliliters. We may pour it in different container and it will have different shape, but the volume is constant, definite. It's like we saying the person will come. Oh, definitely she will come. Definitely, it means sure, constant. All right. Slightly compressible. Because the atoms are a little bit far and they can slide over each other, slightly it can be compressed. Under an ideal condition, it can be compressed, but not easy. All right. It can flow because they can glide over each other. They can flow. It's like, in simple terms, saying that can they move in a room? If the human beings in the room are not choked, they can move. But if they are choked, they can't move. That's the whole thing. All right. Now, the density is lower than solid, except water. Now, what are we trying to say here is this. If you consider a particular substance in this volume and that same substance in this volume, if the atoms here are stacked, and if the atoms here are closed but not stacked, let's say the volumes are the same, the volume here is 10 and the volume here is 10. Now, if you compare these two, the density is mass over volume. Now, if the volume they are the same, what is different? That is going to give you different densities. It is the mass. Now, if each circle weighs 1, let's assume we have 1,000 circles here. How many circles are we going to have here? It's not going to be up to 1,000. So it means that the liquid form of the substance is going to be having a less density than its solid form. But the thing is saying that there's an exception. The exception is applied to what? Almighty water. What is happening in water? If you consider water as an example, when water is when water is solid, this is how at a point the atoms are. At a particular point, the atoms may be arranged like this. Now, let's consider this arrangement and then to this arrangement. We are considering the same volume. Here it is solid. Now, when it becomes liquid, it becomes more close. What is the trick? The solid one is having some slight gaps in between them, but the liquid one reduces those gaps. So it is a little bit tricky, and that is what God, I would say, or nature has made it such that living organisms can survive in water. So it's such a peculiar or specular is such a spectacular behavior of the substance called water. When water becomes liquid, the particles get close to each other than when it becomes solid. So at that point, the density of the solid is lesser than the density of its liquid. Thank you. I hope we understand it up to this point. All right. Now, examples of liquids. We know them: water, oil, milk, alcohol, and mercury. Then let's look at this question that you are going to answer. Then why do some solids float in? Why do some solids float if their densities are higher than liquid? Let's forget about water. Water is an exception. Then why? There is a question we all have to answer. Now, the first trick I'll give it to you, of which the rest you answer and submit it when you come to school, is that we didn't say solid to just liquid, but we said that solid of a material to the liquid of that material. So floating and sinking is not when we are comparing the same substance. This is one clue. The other clues, I'll leave it to you. But the second clue is also the density is equal to mass over volume. Now, the thing is, density is controlled by two things, mass and volume. If you are able to manipulate volume, you are manipulating density. But the trick is you may not be able to manipulate mass. But still, if you can manipulate mass, you are also manipulating density. So something floating in something is not because of how the atoms are arranged, but because of how we can manipulate volume. So I expect you to look further for more explanation, and you will submit your answer when we meet in school. Now, application of liquids. What do we use liquids to do? If it is not poisonous, we drink them. We use some for cooking, water. Some serve as fuel, petrol and diesel. Some are also used as lubricants in machines. As we can see, the man is pouring the oil on the gears so that the friction can be what? Reduced. Also, someone is filling his car with the fuel so that he can move. The Coca-Cola we take is in a form of liquid, and we take it. And then those that our parents are using cars, we know they pour in water to cool their engine. It's like that. Even when you are in a commercial vehicle, at a point the driver can stop and say, "I'm to refill my tank because my engine is heating up." So all these are the uses of liquids. All right. Now, your assessment. A student observed that ice solid floats in liquid water, which is unusual because most solids sink in their liquid form. Using your knowledge of molecular arrangement in solid and liquids, explain why this occurred and what this tells us about the intermolecular forces in ice compared to liquid water. It gives you 10 marks for accurate answer. Think through, answer it correct, and submit it when school reopens. Thank you for your attention, and this is your Sir Adasaria. All the best, and continue to learn till we meet. Bye bye.